All right. Hello, everyone. So we shall get started with the session. And today we are going to spend some time and understand a different technique. So I believe you are curious to know the data engineering pipelines and how they are built. The rationale on why I prefer to show you this additional information was not to confuse you all. It was just aimed at helping you all understand what happens behind the scenes automatically. I understand you want to just build your data pipelines and there ends the story. But if you can understand what goes inside, at least a little bit, then it will help you fare well in the interviews. It will help you face interviews with confidence because ultimately you build your data pipelines and support the data scientists in getting the data. Okay. Support the data scientists in deploying their models in production. And you'll support the data scientists to monitor the model real time. And you establish the entire pipeline. But if you really don't know what happens when AutoML is run, what happens behind the scenes, and if you're only confining yourself to, I'm least bothered about what happens. I just understand that I need to establish pipeline, that is connection between different systems and job done. The moment you get into that zone, friends, the bargaining power reduces in interviews, right? You cannot command high salary because you will say that I don't know, I'm very restricted, I'm very confined to my zone. Doesn't work that way. Having a holistic view of everything with respect to data and data engineering and data science aspects, and then specializing in data pipeline building, data engineering is what is expected in the industry now. Go open any job description, you'll understand, right? So they expect you to have bare minimum understanding of what happens. And that is a prime reason why I thought I'll get started with Teapot, though it is AutoML, though there is not too much about understanding algorithms and all that. Right? Where did we touch algorithm? I fail to understand. We just gave data as input to Teapot. It built some pipeline. We just copied, pasted that, job done. The reason why I've shown you that is because behind the scenes, when you run any AutoML on cloud, it would apply these techniques. So now you will have some more command when you talk to people. You will have some more command when you do your work. Right? Please have that open mind to learn new things. And we are not getting into the depth. Absolutely, we are not getting into the depth of data science or machine learning. We scratch the surface just to ensure that we give you additional knowledge which will help you do your jobs better as data engineering experts. Okay, so please, for sure, you need to bear this in mind. And just give me a moment, please. I'll just put my mobile inside. Okay. So let me quickly tell you on what all we have discussed, and then we shall proceed further. I think there is some issue with the light and all that, so let's remove my video. Okay, so we have spoken about Teapot, right? And this is one of the tools when it comes to AutoML. AutoML automates your entire pipeline. It automates your entire data pipeline. Okay. And Teapot, in your entire data pipeline, that is getting your data into your programming language, establishing the connection, then building your machine learning model, then deploying your model in production, right? Then ensuring that your model is used for inference purpose, meaning you ensure that your model which is deployed is used by the end users, right? That's called as inference or serving. Post that, once you get the results, you need to store the prediction values, you need to store the output, and then using the stored data, you need to monitor your model. What if I say that this entire thing is automated? Then why should I pay anyone extra salary? I'll pay that person extra salary who has obviously knowledge about everything. Okay, so that's the area where the world is entering into. And friends, I work as a chief data scientist on 4 different companies. I do consulting for a lot of Fortune 500 companies. And you name a company, head of analytics, head of data would be a known associate of mine. So I closely interact with them. I understand the way world is moving. I understand what are the expectations of the customers. Okay, so please bear that in mind. Whenever you feel that, no, I want to confine myself strictly to data pipeline, teach me nothing about machine learning. Don't even talk about machine learning model. Don't even give me names of those models. If you have such rigid mindset, then it's not going to help, friends. Seriously, it is not going to help. So please have that open mind to learn everything. You specialize in data engineering. You specialize in data pipeline, absolutely. But have at least some basic knowledge about what are those machine learning algorithms which exist. Right? It will help you immensely. It will take your career to the next level. If you have 2 resumes, one resume strictly on data engineering, data pipelines, another resume, this guy knows, say, data engineering, data pipeline, and some knowledge about machine learning algorithms, some knowledge, high level. At least they know that if we use something called as teapot, it will automate the machine learning pipeline part. So certainly this guy who has that additional knowledge, slight edge, should be rewarded, should be paid more. This is called as economies of scope. Okay, the more you know, the more you get paid. Simple. So even if I were to open teapot and show you on what all we have done, we have absolutely, looked at data, we have split the data, given it to teapot, and it has done the entire trick for us. So at least that much knowledge as a data engineering expert one should have, because the new data that comes for model prediction also should undergo such pre-processing. That whatever pre-processing you have done on your data to build your model, the new data also should undergo similar kind of thing. If you have this knowledge, would it not help you as a data engineer? Would it not give you additional insight? Will you not be able to build your data pipeline in a much better manner? Would you not be able to help your data scientists better? So that's what this is all about. Anyways, that aside. So I would not delve deep into teapot. I thought I'll show the deployment part, etc. But I think certain things are not conducive for even me because of because of certain reasons. So I'll do one thing. I'll go to feature tools. Okay, and then I will get into cloud. So we look into Amazon Sagemaker, autopilot. Okay, and then we look into Azure ML Studio. And then we shall look into Google Cloud Platform and the auto ML capability of that. All right. So let's proceed further with feature tools. So even before you install feature tools, you will have to first ensure that you choose appropriate runtime. I went to runtime, clicked on change runtime. I selected GPU, I ran, and I saved it. Okay, and when you click on connect, it is going to help you all connect to the appropriate server. It's going to help connect to the most appropriate server. Done. Connected. So if I hover my mouse on that, it says 25 GB RAM, and then you also have hard disk. Now, Cloud Pickle is a library that you need to install. I just say pip install Cloud Pickle, upgrade. That option will ensure that you get the most updated version. Then we also have something called as Dask, which I've already spoken about, which helps in parallel processing. And parallel processing is not something which is confined only to data scientist job or machine learning experts job. Anyone who does certain amount of programming, they want to do parallel processing. They want to make use of all the cores which are available, okay, on a server. Hence, we need some parallel processing capability. We have also discussed about this. How will it help? If I open Sagemaker Autopilot and if I build my data pipeline automatically, everything will be black box. I just created something, it created something. Would you answer in that way? Or do you want to know what happens under the hood? What happens behind the scenes? Behind the scenes, how are pipelines built? In the entire data pipeline, how is machine learning pipeline built? How is parallel processing happening when you're building your data pipeline? How are multiple cores being considered? Having that knowledge will make you an effective data engineer. Not having that knowledge will make you a substandard data engineer. Okay, so please ensure that you bear all these things in mind, friends. Ultimately, you all should be successful with more knowledge. That is the prime objective. Okay. Then we have something called as feature tools. Feature tools is an auto ML library which will automatically perform feature engineering. A data engineer should understand what is feature engineering. You cannot shy away and say that I don't know what is feature engineering. Right? You should be aware of that. Feature engineering means you take the existing features, okay, you use the existing features and then do some calculations on your existing features. So let me run this. We are loading a specific data set, which is called as Boston data set. This data set has an output variable, which is all about predicting your median house value. How much will be the price of the house? And then you have various inputs. So the output variable is also called as what? Target. So what we are saying is this Boston data set, take it from scikit datasets, import pandas as PD, import feature tools as FE. Okay, you're just importing the required libraries. And then you are loading the Boston dataset into this object Boston. And then when you say Boston.data, it has all the various inputs. And you're saying Boston.feature names. When you say Boston, that's your object name in which this data set is stored. Dot feature names will give you all the column names. And then when you say Boston.target, that would refer to your output variable here. And when you say print from this data frame head of 5, the first 5 rows will get printed. So let me run this as well. Some additional stuff on this one. Now, if you say FT, which is feature tools dot entity set, and you're treating, you're considering ID as Boston, that's the data set name. And when you say es.entity from data frame, what it does is it will create a data frame, and then when you say ft.dfs, this is very important. What it does is it will take your, the Boston data set, and it's taking the data from that, and it's doing addition and multiplication of your numeric variables. So over to click on run. What just happened is something went wrong. As an ethical problem, manipulators. Yeah, it's only for education. Read on this. It should run, not sure. Error entities. Okay, anyways, now I don't want to sit here and then try to resolve this by doing a secondary search. And I'll try to fix it, and tomorrow when I run it, I'll show that. But what it does is, when you do this add numerical variables and multiply numerical variables, it will take all of your numerical variables, it would add all the combinations, or it will add all the columns. All the columns it's going to add. So B plus CRM, B plus RM, all the columns it's going to add. And you're saying multiply the numeric variables, so it will also multiply all the numeric variables. Next time when you see any AutoML algorithm, and if it performs this activity automatically, you know what's happening. Okay. So now let us get into Sagemaker. You need to go to aws.amazon.com, okay, and you need to sign into the console. When you sign into the console, of course, you need to create your account, and then you need to sign into the console. And here, this is my username and password that I created. You log into this. Once you log into this, you need to do multiple things. One is go to services and go to S3 bucket in that. Or let me search for S3. I'm going to just open S3 bucket, the service. It's taking a while. Okay, fine. Here, what I can do is I can say create a bucket. I can give a bucket name as ML on cloud, auto ML. Okay. And then I'll just scroll down and click on create bucket. Creating a bucket is like creating a folder on your computer. And then it created ML on cloud auto ML. Click on that. And I'll say upload. What do you want to upload? I want to upload a file. So I'll click on add file. And I am going to upload bank additional full. This is a specific data set. Oops, let me not take the full thing. Otherwise, it will take a lot of time. Yeah, let me put this. Let me select this and let me remove it. Let me add another file. So I'll select a specific file, a smaller version. So what will be there in this data set? Come on. Yeah. It has bunch of columns. It has bunch of columns. One of the columns is output variable, wherein you have yes and a no. And you have various other inputs. You have 20 other inputs like age, job, marital status, education, etc. And then you have your output variable, yes and no. You can upload. The file got uploaded. So the file which is there on your computer, you just loaded that into something called as S3 bucket. S3 bucket is nothing but a folder which you create on AWS. Then what we do is you go to Sagemaker, just type Sagemaker. You'll see Amazon Sagemaker, click on that. And here we want studio. Here you see studio, studio lab, R studio, etc. You need to click on studio. Okay, and here click on launch Sagemaker studio. Here you're saying launch Sagemaker studio. And here in the launch app, you have something called a studio. Just click on that. That is all that you need to do. And it is creating an environment for you. Forget about all these things. When you open, you'll not see any of these. So you need to click on this icon. Okay. When you click on that, you would see here a drop down in which you have experiments and trials. Okay. In this experiments and trials, you click on create autopilot experiment. Okay. Why is it taking so much time? Just give me a minute. Experiment and trials. Strange. Let me refresh this once. Come up. Oops. My God. My God, sorry. So I'll close this as well. Yeah, this is how the look and feel will be, friends, initially when you start. Now, when you click on create experiment, it creates an experiment here. You give a name. Let me say ML on cloud auto ML. Then you're saying find S3 bucket. Here you're giving bucket name. And the bucket name is ML on Cloud this. This is what we have created. It is like a folder that you guys have created. Then you select the file name. This is a file that we have uploaded. And then here you can select auto deploy. Just switch on that option, auto deploy. Okay. And outputs, whenever you use your model for inference purpose, for future prediction purpose, after deployment, all those results, prediction results would be stored. Where do you want to store it? I want to store it in the same folder or same bucket. And then you click on create experiment. Okay, sorry. The target variable in this data set, the output variable that we wanted to predict was this y. It was given as y. You see here. The output variable name is y. Okay. Yes and a no. If there is a marketing initiative, if there is some marketing which is performed, based on that marketing which is done, or based on an offer which is given, would a person take that offer or not take the offer? For example, apply for HSBC credit card and get 10% discount on iPhone. In that way, they give some offers, right? If the offer is given, would someone accept that offer? Means yes. If that person does not accept the offer, answer is no. Okay, so you select yes. That is your target variable, not yes. You selected y. All other things are your inputs. Now you click on create experiment. With auto deploy on, it will automatically create an endpoint and automatically you will be using it. So I'm creating the endpoint. So what is it doing now? 250 different models is what it is going to build, and it's going to take hours to build that. Now, do you know what is happening behind the scenes? You don't know. If I didn't explain you about teapot, you would have been clueless on what is happening behind the scenes. But then I already explained you about teapot. What did I talk about that? Let me open the notepad. Teapot. Yeah. In teapot, when we have run that, you understand that pipelines get built. Pipelines get built, and the best pipeline is getting built. Now, did I tell you that you need to know what is support vector classifier and all these things? No, not needed. Even a seasoned data scientist with 10 years experience might not know each and every attribute which is given here. However, I told that after saving that file, just open that, copy and paste the libraries, copy and paste this pipeline and run it. This is your best pipeline which is automatically built. Now, if I go here and if I say that 250 different models are being experimented, you know that behind the scenes, this is what it is doing. It is trying to optimize and find the best machine learning pipeline for you. That now probably you'll be able to connect the dots. Why did we spend time on teapot? For this purpose. Here it is all automatic. What happens behind the scenes is black box for you all. Meaning you don't know what is happening behind the scenes. And if I did not even explain teapot, and if I would have directly brought you here, you'd be like, okay, everything is very fancy. Automatically everything is getting done. And you would have felt happy, but you would have lost an opportunity to learn what is happening under the hood. Behind the scenes, what is happening is something that you would not have understood. Okay. So what your ML on Cloud here does is, It will pre-process the data. Okay. It will create various candidate definitions, different pipelines, candidate definitions, which different pipelines will get generated after data pre-processing. So what is it doing in pre-processing? Autopilot is shuffling the data, splitting the data. I explained you that data has to be split. Okay. So you get the most accurate results. Then candidate definition, then feature engineering. Feature engineering, I have told you through feature tools. Okay, we have looked at feature tools. And what is the reason why we have looked at feature tools? Because I wanted to show you what is feature engineering. Feature tools automatically performs feature engineering. So what did it do here? It has taken all the numerical variables, it has done additions. It has taken all the numerical variables, it has done multiplication. In that way, you have bunch of other operations that you can perform. It's not just these. Okay, you have bunch of other operations which can be performed. Like you can calculate averages, you can calculate maximum value, you can calculate minimum value, you can calculate standard deviations, standard deviation values, and a lot of things you can do. Okay, next. So let me go to, after that, model tuning. So it will experiment various models. Okay, it will here candidate definitions, define various models to be experimented with. Feature engineering, it does the feature engineering that I've just shown as part of feature tools. I mean, similar kind of thing it does. Then model tuning, it will experiment the pipeline of different models and give you the best model. It is going to record something called as SHAP values, etc. I'll not get into the depth, otherwise you might not feel good about it, right? And then it generates certain insights about all the models that are built, the hyperparameters which have been experimented and all that. And finally, it deploys the model. So I shall probably wait for another 2 to 3 minutes to see how the progress goes. Okay. And then we'll talk more about it. Just let us allow 2 to 3 minutes for this to complete. Now, what we will do is once the model is deployed on the cloud, automatically everything is built. There is no role of a data scientist. There is no role of a data engineer. Right? There is no role of data analyst. Everything is automated here. Right? Even a layperson with no knowledge can just use certain options and job done. Okay, so let it take some more time, that's okay, and let it move on to the next phase. While it does that and while it moves to the final stage of deploying the model, we will also do one more thing. What is it that we are going to do? After the model is deployed on the cloud, we shall, from our local computer, that is from our laptop, from the laptop or your local computer, we are going to invoke this endpoint. Endpoint is a final place where your model is deployed, hence it's called as endpoint, final point. Right. You'll invoke the endpoint and you supply the inputs. You're going to supply inputs to the model. So if you look at this data set, You will say what is the age, what is the job, what is the marital status in that way, what is education in that way. You supply all these inputs right until here, and then you will ask your model to do the prediction. When you ask your model to do prediction, it will all the way go to this cloud where your model was deployed. It will use your model and then give you the final prediction. Okay. It will finally give you a prediction, the prediction output that would get displayed on your computer. Okay, this is what we need to do. To perform this activity, I'm going to open something called as Anaconda. So friends, there are multiple ways of downloading Anaconda. Just say download Anaconda. You'll get hold of something called as Anaconda distribution. Click on that and click on download. Based on whether your machine is Windows or Macintosh or Linux, it will automatically download Anaconda distribution for you. Just click next, 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 and done. The installation of Anaconda would be done. Then go here, then open, type Anaconda, and open Anaconda navigator with a green symbol. It has a green symbol here. Click on it. So it's opening up. Yep, I think Anaconda is here. It is okay. So Anaconda opened up. Now what you need to do is create a different environment. Create a different environment. Okay. And how are we creating that environment differently? Okay. So there are multiple ways of installing basically. You just need to go to environment here. Now we are in environment. Okay. And you can click on create. There is an option called create. Just type your environment name, ML on cloud auto ML in that way. Just give the name of your environment and click on create. And it is going to create an environment. Or if you're fancy about typing code, if you love typing code, do a drop down here, click on open terminal. This is the hard way. Easy way is just click on create, it will create a different environment. Like you have Sagemaker, ISB, AMPBA, Sagemaker, AutoML. In that way, a new environment will get created. So what we will do here is we will type certain lines of code because I think people are happy if lines of code are written. So Kunda create -y -n. These are just arguments you can type and then you'll understand. So here I want to give a name. What name shall we give? ML on cloud. Let me give a same. So what it does is it will create an environment. It will come, it will get refreshed and it will come. Now you say Kunda, activate that environment. Make that environment active. Which environment? ML on cloud. So that is the name that we have given, friends. You can give any name of your choice. and here it's going to activate that. It's going to get into that. Now you can install the libraries. There are certain libraries that you need to install, okay, like Boto 3. Boto 3 is an SDK which will help you connect from your local computer to your AWS. It's Python SDK, right? So let me type it and then you'll understand what name I'm talking about. So just say funda install -y. These arguments are a bunch of arguments exist on how to install and all that. That's out of scope anyways. Boto 3, and I also want to install, say, pandas. I'll enter. Now, Boto 3 is a Python SDK which will help you connect your Python to AWS environment. Python to this AWS environment. So it's still doing features. Right? So let us come back here. It's installing everything. Done. It installed. Now what should you do? You have to install. If you see here, ML on cloud, auto ML got created. A new environment got created. Okay. And if you want Jupyter as an IDE, integrated development environment, then you can just type funda install Jupyter. Okay, so it's just installing that. Let it install and then things. Okay. After this, we will install a library called as Sagemaker. Sagemaker is a library, right? So let us do our installation of Sagemaker library. And installing Sagemaker library is very simple. You just say pip install like any other library that you install in Python. This is how you install. So what are the various things that we have done? We have created an environment by writing code. Otherwise, just click on create and create. It will get created. And then we have installed Boto 3, pandas, and now we have also installed Sagemaker. And we have also installed IPython kernel, which is nothing but Jupyter. Jupyter IDE, integrated development environment, which only has some look and feel. Okay, done. Now I'll say go to say you have Python 3. This one. Install. ML. What is an engine? ML on cloud auto. Let's just remove it. it installed the kernel specification. Now, if I click on this ML on cloud, you need not even click on that, right? So, where is this? Here. If you just type Jupyter Notebook, it will open the Jupyter Notebook for you. Directly it opens here. When you do a drop down on new, you see ML on cloud auto ML. This environment got created. So what's happening now is feature engineering. After that, model tuning will happen. After that, explainable report, so on and so forth. Until this gets created and all that, let's not wait. Instead, what we can do is 28 days back, I have a trial that I got created. So I'll get into the trial window. I think I deleted all the endpoints, if I'm not mistaken. About this. So all these trials and endpoints are, I believe, deleted. So that's okay. Let us wait until our experiment, is complete. So it would take its own sweet time, friends, to complete this particular, pipeline, end-to-end pipeline. Once it creates end-to-end pipeline, what will happen is you'll also be able to see the end point. And once you see the end point, you can very simply go here. Where is that? Created here. Okay, click on this ML on cloud. Okay, and it opens this. Here you need to type certain lines of code. Okay, and these lines of code, you would be able to actually use it only after the endpoint is created. Here, after this entire process is done, it will take roughly an hour or so, because we are talking about 250 models, and we are talking about a lot of amazing feature engineering, automated feature engineering behind the scenes, right? So all that has to happen. I will not close this. I will let this entire experiment continue, so that tomorrow I might go to my local computer. Okay, here it's, and then here I'll issue the commands, and then I want this local computer to connect to this model which is deployed on cloud, and then bring me back the results and display the results on the screen. This is what I want, right? So let me brief you on what happened until now. As part of our auto ML journey, when we started, we thought about discussing open source tools and cloud-based tools. And I've also told that when it comes to Sagemaker, Autopilot, etc., it is just about drag drop or just select the options and it will take care of entire thing. But if you are familiarized with what happens behind the scenes, it'll be easy for you to understand the concepts. Hence, we have spoken about teapot. And also, we have spoken about multiprocessing using Dust. I thought of showing you the deployment of teapot also, but then I'm a little taken aback because maybe you won't be comfortable or you're not comfortable learning certain things. So I switched the gears there. And we discussed about instead feature tools. At least you now know that Teapot will automate your machine learning pipeline, and Teapot automatically performs your feature engineering. Now, these two, how will it help you? It will help you in understanding on how the AutoML operates and how SageMaker Autopilot or any AutoML cloud-based solution works. And here, what did we do? We loaded the data in S3. We started SageMaker Autopilot. We just supplied the data here. We just selected the output variable, and automatically based on your output variable, it figures out what kind of problem it is. And it's experimenting with 250 plus different models now. And finally, after it builds a model, it builds all the candidate models. That is the term that you use, candidate, all the models. And then it will automatically deploy the model on an endpoint. Then what are we doing? We are trying to invoke the endpoint from our local computer, but for that we had to do some operations. Okay, we had to do some operations and we had to set up our local environment. We are setting up the local environment, and what we shall do is, once the model is deployed on the endpoint, this is on cloud. Automatically deploying is on cloud. So from local machine, you will give your inputs here on your local computer. Then it will go to your model here, and then it will invoke the endpoint and get your predictions. This is exactly what happens. Okay, there is a very good question here, and the question is, if you create an environment by clicking on a button here, when you give a name and select the appropriate whatever version of this thing, and then when you click on create by giving a name, do we need to still install Jupyter, etc.? Let me show you that. Let me create. So earlier, Jupyter here we installed it, okay? We manually installed it. But then when you create a new environment, right, this is how it will appear. And you have to manually click on install and it will install. After installing that, what about the various libraries? Do I need to also manually install that? Yes. You need to click on this, click on open terminal, and then you have to say pip install. Whatever Boto3 and SageMaker, for sure, you need to install that. Pandas will automatically be installed because of Anaconda. When you install Anaconda, the most widely used Python libraries are automatically installed. Right? But Boto3 and SageMaker, you'll have to install. Okay, installing that is certainly needed. Okay. So back to this. Now it went into the next phase of model tuning. Autopilot is tuning your models with hyperparameter optimization. Automatically it is doing it. But now that we have already invested sufficient amount of time on teapot, you will understand, okay, what do you mean by hyperparameters? What are the various options that get, tuned, so on and so forth. It helps, friends. Without your knowledge, it will help you. Entire data pipelines are getting automated. All that rigmarole of installing the softwares on your computer and then doing it, everything is gone. Okay, automatically, it is doing various things. So I will stop here, and tomorrow when we connect, affirmatively this part would be completed, and then we will make use of our local computer, and then we will give inputs, and we will see the outputs on a screen. But outputs are obtained by connecting to your cloud installation. So that's how it works, friends. Okay. All right. Thank you so much. We'll stop here, and then we will talk about deployment tomorrow. You can also install Boto 3 directly through, no, you'll have to go to terminal and then install. No, here you do not have anything called as minimum time or maximum time that you can give. No such parameters exist. But you are able to ask that question because you actually looked at teapot, right? That's a good part. But then now, no, you do not have that option, unfortunately. Okay. All right, so I'll stop here, and we'll take this discussion to the next level tomorrow. Thank you all.